We all ask, what if? What if I miss my train? What if I'd said something different? But what happens when science itself starts asking those questions? Well, today we're going to dive into some of the most mind bending what ifs out there. And more importantly, we're going to see why this one simple question is one of the most powerful tools we have for understanding reality itself. Okay, let's kick things off with a scenario that sounds like it's straight out of a disaster movie, but it's grounded in some very, very real physics. Right now, as you're sitting there, you are hurtling through space at over 1,600 kilometers per hour, but you don't feel a thing, right? That's because everything, the atmosphere, the oceans, you, is all moving together in perfect sync. So, what happens if the Earth suddenly, for just 1 second, slams on the brakes? The answer, in a word, is inertia. It's Newton's first law in the most terrifying way imaginable. See, the planet itself would stop, but everything on it, you, the buildings, the oceans, the entire atmosphere, would keep right on going at that original speed. Everything that isn't literally bolted down to bedrock would be violently scoured from the surface, becoming a supersonic projectile. The consequences would be instant and absolutely catastrophic. The oceans would surge into continent-sized tsunamis, literally reshaping the land. The atmosphere would turn into a global, supersonic windstorm, strong enough to just flatten cities and strip landscapes totally bare. It would make every natural disaster in human history look like a little storm in a teacup. So why even bother thinking about something so absurdly horrible? Well, because beyond the spectacle, it actually serves a really crucial purpose. This kind of question is a fundamental scientific tool. By imagining a world where a core rule of physics is broken, we get a much deeper, almost gut-level appreciation for just how delicately balanced our own world really is. This whole process, it has a formal name. It's called counterfactual thinking. And honestly, we all do it subconsciously all the time to figure out cause and effect. But when scientists use it, it becomes this incredibly disciplined thought experiment, a powerful way to explore questions that are just impossible to test in a real lab. And this is not some new idea. Scientists have been using this tool for centuries. Galileo used it to imagine objects falling in a vacuum, which totally challenged what people believed about gravity. And here you see Einstein, who used it to ponder the very fabric of reality. Asking what if isn't just some idle curiosity. It's right at the heart of how we make scientific discoveries. All right, so let's see this tool in action. We're going to explore two really famous what-if scenarios, one from physics and one from biology, to see just how a seemingly simple question can unlock some profound truths about our universe. First up, a classic thought experiment that really shows you the extreme laws of our universe. This question was asked and answered by Randall Munroe, the genius creator of the webcomic XKCD, who is amazing at applying serious science to completely absurd hypotheticals. So, what actually happens? The answer isn't just a big explosion. I mean, it is a big explosion, but it's so much cooler than that. When you break the problem down, nanosecond by nanosecond, this impossible question turns into this stunning illustration of relativistic physics and nuclear fusion. It shows you what happens when the rules of our normal, everyday world smash headfirst into the fundamental laws that govern the stars. Okay, now for a totally different kind of what-if, one that rewrites our own origin story. For more than 100 million years, dinosaurs dominated this planet. What if that asteroid that wiped them out 66 million years ago, what if it had just been a near miss? Would we even be here? Well, here's where we see this core difference in how life evolved. Paleontologists argue that for millions of years, the winning strategy was just get bigger. But after the asteroid hit, the whole rulebook was thrown out. With the giant predators gone, mammals suddenly faced intense competition with each other. This new pressure created a totally different winning strategy. Have fewer kids, invest more in each one, and ultimately, the rise of adaptable intelligence. The key takeaway here is that a single, random, catastrophic event can completely reset the game of evolution, creating opportunities for entirely new ways of life to flourish. So from the nanoseconds of a baseball to the millions of years of evolution, we're seeing how this simple tool helps clarify our reality. So now, let's scale it all the way up to the ultimate conclusion and ask the biggest question of all. What if the universe itself were different? Scientists have discovered that our very existence hangs on just a handful of numbers, things like the strength of gravity, the mass of tiny particles, and they all seem to be balanced on a razor's edge. If you just tweak them even a tiny, tiny bit, everything changes. Change any of these values, and the universe as we know it, with stable stars, complex chemistry, and life, it just couldn't exist. For instance, a neutron is just a tiny bit heavier than a proton because the down quark is a tiny bit heavier than the up quark. If you flipped that, protons would just decay. No protons, no atoms, game over. You'd have a universe filled with neutrons and radiation, and nothing else. This baffling observation is known as the fine-tuning problem, and it leads to this fascinating and, pretty controversial idea called the anthropic principle. Basically, it suggests that the reason we see the universe with these life-permitting values is, well, because we exist. If the values were any different, we wouldn't be here to observe them in the first place. And this just sparks a huge debate. Is this evidence of some kind of design, or did we just win an unimaginable cosmic lottery? So why does any of this matter to us, really? Because asking these what-if questions, from relativistic baseballs all the way up to the cosmos itself, gives us these real, tangible benefits for how we understand our world and our little place in it. Psychologists and philosophers have pointed out a few key payoffs. First, this kind of thinking lets us run mental experiments to understand cause and effect. I mean, imagining the Earth stopping helps you feel the power of inertia. Second, it creates contrast. It helps us appreciate our reality by vividly imagining what could have been. Our own existence feels a lot more profound when you consider a world still ruled by dinosaurs. And finally, it gives us what the Germans call Spielraum, which basically means room to play. It's an open, intellectual space for curiosity, and that is the very wellspring of creativity and new discoveries. And that brings us to one final, mind-bending thought that circles all the way back to our finely tuned universe. If our existence seems so improbable, so totally dependent on these perfectly balanced numbers, how did we get so lucky? Well, one potential and, pretty wild solution to this fine-tuning problem is the multiverse hypothesis. The idea is that our universe isn't special or designed at all. It's just one of a possibly infinite number of universes, and each one has its own random set of physical laws. We just happen to live in one of the lucky ones where the laws turned out to be just right for life to emerge. And that leaves us with the ultimate what if. It's a question that completely reframes our entire existence. Are we the inevitable result of a cosmos that's perfectly tuned for us? Or are we just the improbable winners of some cosmic game of chance? The question itself is a testament to the power of our curiosity, and it invites us to keep asking, keep imagining, and to keep exploring.